So, good evening, all. Our project proposal is based on the vision assistance for public transportation. We are the team Pathfinder. I am Sukhavashni and my team members are Shivani and Pooja. So, why do we choose on this? Our statement is to address the visually impaired people who face the significant challenges in navigating the public transportation due to their inability. For that, our project proposal will help them to guide their navigation by identifying the bus numbers and the destination location based on the camera module which we are going to capture the content through that, in which we are going to process the bus number and the destination through ML processing and AI. So here's our overall approach for the bus assistance system, in which the system leverages Torch CUDA for the GPU accelerated video processing and OpenCV Python for image handling, and ECOCR and Paddle OCR for the efficient text recognition. By utilizing these techniques with the Torch and Torch Vision, it ensures the accurate and the fast identification of the bus number and also the destination details mentioned on the bus, which ensures the accuracy and efficiency of this project solution. So here's our objective. Why do we go for this? Means to detect the bus numbers and the destination utilizing the computer vision and the OCR based text recognition techniques. Along with that, we also provide the real-time audio processing by utilizing the real-time extraction of the contents in the video processing also. Along with that, we ensure the high accuracy and speed using the Torch CUDA for GPU acceleration, in which it enhances the public transportation accessibility for the vision people. So here our proposed solution. The first task will be based on the camera module. The camera module which captures the real-time video of the bus. By using the OpenCV Python, we will capture the bus number utilized for image processing to enhance the text clarity and also the text recognition. After that, there will be a bus number and destination detection. For that, we will using the ECOCR and Paddle OCR to extract those text. After those processing systems, the final output will be based on the audio feedback to the users. The audio feedback will be through mobile phone or through the microphone wristband technique also. The prototype will be changed along with the customization towards the final product. The audio feedback will be based on by conversion of the speech output using a text-to-speech conversion. While using the extraction process, the system will produce a text format details of the bus number and the destination place, in which that we are going to use the Google API or the GTTS module, in which helps to convert the text to speech for the end user. This system audibly announce the bus number and destination to the visually impaired user. So here's our flow architecture. The main sources input blocks are camera module or the touch screen, in which captures the bus number, also the destination. The processing unit will be the software unit. The product will be based on the output of the audio based. So the previous content which we are saying is the final product based solution. As for now, the prototype level, we have been implemented this technique and solution through the software by utilizing the tool Google Colab. In the Google Colab, our approach starts from by connecting the Google Drive, along with that installing the important file details. Also that we have trained the specific bus numbers along with the dataset which we have captured as images in the live. For that, currently we have chosen the two bus specifications. The number based on one is 21A and another is 90A. These two bus numbers datasets have been collected and stored here as a datasets as separate folder. Using these datasets, we are including the input file as the input file given here. So this This prototype consideration is linking with to the final product. How it is means, here our software generates one icon which helps us to input the file as by choosing one in the device. The file is imported from our desktop or devices, in which the image is being matched with the current dataset which we have already trained using the models like sklearn. Here we have used the models as sklearn and TensorFlow. So the implementation, to begin with that, first we have to connect this with our Google Drive. After connecting with that, we are importing our dataset files as zip format, and also the necessary modules like OS and PIL. After doing with that, we are reading the parameters for the imported data. Also the main parameters which we have deducted, based on that we are going to process those parameters. For that we are using the modules CV2 and NumPy. After doing that, we have to train the model. For training the model, here we are using the sklearn and TensorFlow. Using those tools and modules and libraries, we are training the bus numbers along with that data set. Also the training the important parameters like bus number and destination details. For example, here the 90A bus means it's moreover the destination towards the place called Somanu. For that we are matching the parameters in the different bus formats which we have captured as images in the real time. So after doing that, the sklearn model will train those data sets and kept as a folder here. After that, the TensorFlow will works upon the input which we are giving to the input file. So here's the data set readings. So here our model which we have trained using that. So this is our final code. So this is our final code format for the processing of image. Here we have imported the modules PyTestRact to extract the text content in the bus image. Also the GTTS, which helps us to convert the text extraction to the speech as output. So here the icon pops out, in which we are going to choose our input file as a bus image. This code is mainly optimized for the bus image processing system. For that, the processed image will give us the detail of the number along with the destination as voice output. So here we have given the input as this image. This image not contained in as the data set. This is a separate image which doesn't match with the pre-trained data pattern, but it trains the specific bus number along with that location. So here's our output.
Bus in 90A Somanur செல்கிறது.
So we have tried this audio output in the like regional languages pattern, along with that in English also.
Bus number 90A Somanur Selkaradu.
So these are the tools which we are installed for the text extraction and also the voice output. So this kind of prototype level approach is mainly focusing on the image based processing technique. So this is our outline of the project idea. So for the main execution, we have to go the one step ahead of the video based processing. For that, here using the same Colab, here we have inputted the file as the video format. After the file, we have installed the main modules for this video processing, mainly the Paddle OCR and the CV2. Using this modules, we have been extracted the main parameters for our project by using this code. So here you will be seeing the approach of our project by how we are going to approach this means by splitting out the video into the specified frame rates. So for the video based processing as well as the image based processing techniques, we have used the coding language for these is Python. So for that, we have extract the text content from the video using these code lines, and also we have converting the colored format content into the OCR pattern. Also that the text will be processed based on the Paddle OCR module and the CV2 module. So here's our parameter readings based on the frame rate which we are going to capture that. So these are the frame rates which are saved as the JPG format from the video content. Using the MATLAB, we are going to display these three frames. Here for example, here we have implemented the frame rate extraction. This is our sample image, in which you can see that the image has been perfectly extracted the content of the bus number 90A and also the location detail of current display KMCH. So as for now, our progress is mainly focused towards the accurate frame extraction from the video, which could be of more accurate towards of around 90%. As for now, we are working towards of the accuracy level of 60 to 70%. So these are our frame pixels which we are so here we have processed the frame rate of up to 328 pixels for the video rate of around 10 seconds. This is our video content extraction of the sample image. So after that, currently we are working on towards the conversion of these pixel rate extraction towards the audio output. For that, we have currently working on towards these codes. So our current progress is to work on a more frame extraction from the video content, as we have now see the sample video processed frame rates. Our aim is to get more accurate and proper audio output to the user. So we are currently working on towards using these codes. So this is our progress to our project solution, and we are more yet to work towards it as a complete prototype model within this week. Thank you.